Okay, friends, in the first lecture mainly we have seen what is row echelon form of a matrix and what is row reduced echelon form of a matrix. And in this second lecture we are going to see how we are going to use this technique in solving a system of linear equations. Okay. So, suppose now that we are having n m equations in n unknowns. Okay. So, first equation is a11 into x1 plus a12 into x2 and so on and so forth plus a1n into x1 is equal to b1. First equation, second equation and so on and so forth, m equations and n unknowns. We want to solve this equation. How we are going to solve? First of all, this matrix has to be converted into this system of equation has to be converted into matrix equation of the form Ax is equal to P that we have seen in the first lecture. Ax is equal to P. What is A? A is the coefficient matrix that will be formed from here, and X is the column matrix which are unknowns x1, x2, xn, and B the column matrix b1, b2, bm. So, write this matrix in the form of Ax is equal to B. See the second slide, Ax is equal to B, that we have seen in the first lecture also, how to write a given system of m equations in n unknowns in the matrix equation form Ax is equal to B. So, I believe that the moment the equation is given to you, we should be able to write in the form of Ax is equal to B, that is matrix equation. So, I believe that this step is clear. Let us see, second step is find augmented matrix, that I have also defined in the first lecture. What is augmented matrix? That is, augmented matrix is first the coefficient matrix A, then the last column is the column matrix B, that is b1, b2, bm. This is called augmented matrix. Okay. So, you can put one line also, that is there no problem. This is one, put one line, so that left to this, this is your matrix A and the last column is the matrix B. So, this is called augmented matrix. So, at this stage we know if a system of equations is given with us, then how to write in the form of Ax equal to matrix equation and how to find augmented matrix. Now, when augmented matrix is known to us, then we will have to see that what is the meaning of row rank of a matrix. Row rank of a matrix. See that matrix, suppose the matrix A is given, you want to know what is the row rank of a matrix, then transform that matrix, that given matrix, either in row echelon form or in row reduced echelon form. How to convert the matrix A, given matrix A, in row echelon form or in row reduced echelon form with the help of 3 elementary row operations that we have seen in the first lecture, and therefore, I shall assume or I shall believe that you should be able to convert the any given matrix in row echelon form or in row reduced echelon form. Then see what is the number of non-zero rows in row echelon form or in row reduced echelon form. That number is called row rank of a matrix. That is, number of non-zero row in row echelon form or in row reduced echelon form of a matrix is called row rank of a matrix. Row rank of a matrix. And I shall use the notation here RA. RA means row rank of the matrix A. Now, suppose Ax is equal to B, this system it is given, we want to solve. So, first of all you find RA, means first you find what is row rank of A and what is AB. AB means this is your augmented matrix, this one is your augmented matrix. So, find the row rank of augmented matrix also. If both are not equal, then what happens? If row rank of the coefficient matrix A is not equal to the row rank of the augmented matrix, this will imply that solution does not exist. Solution does not exist means the system is inconsistent. We shall see by one example. Solution is system is inconsistent, the solution does not exist. Whenever row rank of A is equal to row rank of the augmented matrix, that will imply that system is consistent. So, row rank of the coefficient matrix A is equal to the row rank of the augmented matrix AB. It will imply that solution exists, that is system is consistent. When system is consistent, then we will have to see how many solutions. Solution is unique or infinite number of solutions. These are the only two possibilities. The moment system of equation is consistent, then you will have to decide, or we will have to decide, that whether the solution is unique or we are going to get infinite number of solutions. So, if row rank of A is equal to row rank of the augmented matrix is equal to number of unknowns, that is n, then we shall say that solution is always unique. Solution is unique. I shall also give one example for this one. Third is that suppose row rank of A is equal to row rank of the augmented matrix, but it is less than the number of unknowns, then you will get infinite number of solutions. In this case, we are going to get infinitely many solutions. So, we shall see 3 examples. Out of these 3 examples, one example we shall see in detail, other example you can see yourself, but I shall explain. So, for consistency, what we have seen, that row rank of A must be equal to row rank of the augmented matrix, and if this is equal to the number of unknowns, then solution is unique, and if this is less than the number of unknowns, we will get infinite number of solutions. When row rank of A is not equal to row rank of the augmented matrix, system is inconsistent, and therefore, the solution does not exist. Let us see one example here. This is a system of linear equations, 3 equations, 3 unknowns it is given to us, okay, and we want to solve this, or we want to find what is the solution of this. Let us see first of all, what is the first task? Convert this matrix in the form of Ax is equal to B, that is, find what is the coefficient matrix A, what is the coefficient matrix B, and what is the matrix X, that is x1, x2, x3, that is unknown. And then you find augmented matrix, okay. So, look at here, in the second equation 2x2 minus 8x3 is equal to 0. So, if nothing is there, means 0 into x1 is there, coefficient of x1 is 0, coefficient of x1 is 0. So, therefore, if you want to find matrix A, then the first row will be here 1, minus 2, 1, second row will be 0, 2 and minus 8, third row is minus 4, 5 and 9, okay. So, look at here, this is the augmented matrix, Ax is equal to B, and from there you can get here the first one. If you look at here before this line, first one is the matrix A, this is the matrix A coefficient matrix, and this is the matrix B, that is RHS part B1, B2, B3. So, we are getting here augmented matrix. Let us, and we want to see whether solution exists or solution does not exist. If row rank of this matrix, coefficient matrix A, is equal to the row rank of this whole augmented matrix B, that will imply that solution exists. Then we shall see whether solution is unique or it is not unique. And if these two ranks, row ranks, are not equal, solution will not exist, okay. So, our basic first task is that convert this augmented matrix, this whole matrix, this augmented matrix, into row reduced echelon form of the matrix. So, look at here, we are lucky that here it is already 1. So, leading entry is 1, so there is no problem at all. Below this one, all entries should be 0. So, here it is 0, again we are lucky, here it is 0, but here it is minus 4. So, this one we want to make to be 0. So, how to make this one to be 0? We shall make so we shall multiply the first row, that is multiply the first row R1 by 4, R1 by 4, multiply first row by 4, then you add it in the third row, you see that you will get here 0. So, that is, then first job will be over. Look at here, this equation has been written in this form, okay. As I have explained that you replace R3 by R3 plus 4 R1, so that this element will be 0, okay. So, see that this element is coming to be 0. So, this is also 0, okay. What is the second stage? Second is that, see the second here, if it is non-zero, it has to be 1. Then how to make this one to be 1? you multiply this second row by half, multiply the second row by half. So, this will become 1. Okay. After that, the moment it is 1, you want this one to be 0. Okay. When this element is 1 and this is, then this should be 0. So, after making this one to be 1, then what we shall do? We shall multiply this second row by 3 and then we shall add it to the third row, so that this element also becomes 0. That is the usual technique. So, this technique is very simple, but very useful also. So, let us see that we are taking this element 2 as pivot element, we shall make it to be 1, that is R2 has to be replaced by half into R2. Then you see that now here 1 is there. Now, make this one to be 0. How to make this one to be 0? Make this second row, multiply this second row by 3, add it to the third, we will get here to be 0. So, by that, see, we have replaced R3 by R3 plus 3 R2, we are getting here to be 0. Look at here, now this matrix is in this matrix A, this is in row echelon form or no? You see that obviously this matrix is in row echelon form. When this matrix is row echelon form, then you see what is this matrix is, this matrix up to here, this matrix is the matrix A. Okay. So, what is the row rank of this matrix A? Row rank of this matrix A. Row rank of matrix A means number of non-zero rows in the row echelon form of the matrix. How many non-zero rows are here? 1, 2, 3, all 3 are non-zero rows. Therefore, row rank of the matrix A is 3. Look at here, the whole matrix, this whole matrix up to here, this is also in row echelon form. When this is in row echelon form, number of non-zero is also 3. Therefore, number of non-zero is 3 means row rank of the augmented matrix AB is also 3. So, row rank of A is equal to row rank of the augmented matrix, and that is equal to 3, and that is equal to number of unknowns. Look at here, if row rank of A is equal to row rank of the augmented matrix, solution exists. And when this is equal to the number of unknowns, number of unknown here is 3 and row rank is also 3, therefore, solution exists and it is unique if in fact. Therefore, what is the solution? So, look at here, what is the meaning of this one? 0 into x1 plus 0 into x2 plus 1 into x3 is equal to 3. So, x3 is equal to 3. What is the meaning of second? Second row means what? 0 into x1 plus 1 into x2 plus minus 4 into x3 is equal to 4. So, that is x2 minus 4 x3 is equal to 4. What is the first one means? 1 into x1 minus 2 into x2 plus 1 into x3 is equal to 0. That is this one. Okay. So, when x3 is known, look at here, x3 is known, substitute the value of x3 here, you will get x2. Okay. So, substitute the value of x3 means 3. So, minus 4 into 3, that is minus 12, then x2 will be here minus 12, it will be here 4 plus 12, 16, and so x2 will be 16. Now, when x2 is known, x3 is known, so substitute the value of x2, substitute the value of x3, calculate x1. Therefore, x1, x2, x3 all are known. This is called back substitution in fact. Okay. That I have explained that this matrix is in row echelon form, and when row rank of A is equal to row rank of the augmented matrix, therefore, solution exists and it is equal to 3, that is number of unknowns, therefore, solution is also unique. Okay, solution is unique. In this fashion, we can find the value of x1, x2 and x3, and that when we are using back substitution in a row echelon form, what is the meaning of back substitution? Look at here, back substitution means first x3 is known from here. When x3 is known, substitute x3 in the second equation, you will get x2. Now, when x2 and x3 are known, substitute in the first equation x2 and x3, x1 will be calculated. That is called back substitution. And when we are using back substitution in row echelon form, when we are using back substitution in row echelon form of a matrix, then this method is also known as Gauss elimination method. Gauss elimination method or back substitution method. Okay. Therefore, you can see that with the help of this back substitution method, you are going to get the solution as x1 as 29, x2 as 16 and x3 as 3. So, here solution is known. Suppose you want to use I shall say specific that if you want to convert the given matrix A into row reduced echelon form, then also we can find the solution. Okay, and that has again a special name, that is called Gauss-Jordan method. Gauss-Jordan method means we will have to convert the given matrix A, that coefficient matrix, as well as the augmented matrix into the form of row reduced echelon form, not in row echelon form. Remember here, if you are using back substitution in row echelon form of a matrix, we shall say it is a Gauss elimination method. When we are finding solution with the help of converting the given matrix A into row reduced echelon form, then we shall say that it is Gauss-Jordan method. So, let us convert this matrix A into row reduced echelon form. Remember that this at this state it is in row echelon form, it is in row, not in row reduced echelon form. Therefore, if we want to convert this matrix into row reduced echelon form, then look at here, at the place of -2 you must get 0, because every element above and below the leading one must be 0. So, here it is the leading one is here, leading one is here. So, above this one here it should be 0, and at place of -4 it should be also 0. So, therefore, if you want to make this -2 to be 0, then what we shall do? Multiply this second row by 2, add it in the first, you will get here 0. So, remember one thing very important, whatever the elementary operations you are applying on A, on the elements of or on the row of the matrix A, same operation at the same time must be applied on the elements of this matrix B also at the same time. That is, what is the meaning? That if you are multiplying the second row by 2 to make this element to be 0, then this of course 0 into 2 0, 1 into 2 2, minus 4 into 2 8, then this 4 has to be also multiplied by 2. Then you add it in the first row, so this element has to be added here also, and then we shall convert again this matrix into row reduced echelon form. Again you want here to be 0 means what? Multiply the third row by 4, add it in the second row, you will get here 0. Again multiply the first row by 1 itself, because here it is 1, here it is 1. If you want 1 to be 0, so subtract R3 from R1, you will get here 0. So, let us see how we are going to convert this matrix A into row reduced echelon form. Now, I have explained to you that R1 has to be replaced by R1 minus R3, so that you will get here 0, 1 0, replace R2 by R2 plus 4 R3, so that you will get here 0. Again, one more operation you can use, that multiply this second row by 2, add it in the first row, so that this element becomes also 0. So, see that final form is coming here. So, see this matrix is in row reduced echelon form, and from here you can find again solution. What is the meaning of this one? This one means again 0 into x1 plus 0 into x2 plus 1 into x3 is equal to 3, therefore, x3 is 3, 0 into x1 plus 0 into x2 plus 1 into x3 is equal to 3, therefore, x3 is 3. From the second row, from here 0 into x1 plus 1 into x2 plus 0 into x3 is equal to 16, therefore, x2 is 16. Here it is 1 into x1 plus 0 into x2 plus 0 into x3 is equal to 29, therefore, x1 is 29. See that we are going to get the same solution, and this process is called Gauss-Jordan method. Gauss-Jordan method means we are reducing the augmented matrix to row reduced echelon form, and then we are finding the solution. So, we have seen the solution with the help of two methods. One is the Gauss elimination method, other is Gauss-Jordan method. Gauss elimination method means by converting the augmented matrix into row echelon form. Gauss-Jordan method means by converting the augmented matrix into row reduced echelon form. See the second equation. I shall be little here quick, because process is now exactly similar, there is no difference. So, you are going to solve this system of equation. In the first equation, look at it, x2 minus 4x3 is equal to 8. There is no x1. If there is no x1 means coefficient of x1 is 0, 0 into x1 plus this one you can take. So, immediately you can see what is the augmented matrix. Immediately write what is augmented matrix. See, there is on the screen augmented matrix is written. So, this one is the coefficient matrix A, this one is the matrix B. The moment we have found or we have written the augmented matrix, then you see that here what you want, this is 0, first non-zero entry is 0. Then we have to see in that column, is there any entry which is non-zero. Then we will have to bring this to that non-zero to be here. If it is 0 here, all elements all below must be 0. If there is any non-zero, that has to come at this place. So, therefore, this either we can replace second row, first row by second row, or first row by third row. It is our choice. At this stage, I am interchanging first row by second. So, first row will be here 2 minus 3, 2 and 1, and second row, this whole first row will come at the second position. 0, 1, minus 4 and 8. This 8 has to come in the second position. So, we are going to get this. Now, let us see, we want to convert either in row echelon form or in row reduced echelon form. So, this 2 must be 1. How to make this 2 to be 1? One way is that we multiply the first row by half, so that it becomes 1. Okay, simple technique. So, we shall do that part. And the moment this is made 1, moment this has been made 1 by multiplying the first row by half, then this has to be made 0. So, when this is 1, multiply the first row by 5, then subtract it from the third row, you will get here 0. Okay. So, let us see. So, R1, first of all, in the second stage R1 has been replaced by half into R1, then you will get this equation. Okay. So, let us make this one to be 0. So, multiply the first row by 5, then subtract it from R3, so that you will get here 0. So, R3 will be replaced by R3 minus 5 R1, so that here at this position you will get 0. That is our aim. So, see now here 0 is appearing, here it is 1. So, it is well, but then here it must be 0, here you must be 0. How to make it 0? We shall multiply the second row by half, you add it in the third row, you will get here 0. Okay. And that you do and see that then what we are getting. Replace R3 by R3 plus half R2, so that this element will be converted into 0. So, look at here, it is 0. What happens here? First of all, look at here, what is the row? Now, this matrix A, this matrix from here to here, this matrix A is in row echelon form of the matrix. What is the row rank of this matrix? Row rank of this matrix. See that number of non-zero rows. One row is 0, completely 0, fine, and these are there are two non-zero rows, first and second row are non-zero rows. So, there are two non-zero rows, therefore, row rank of the matrix A is 2. And what is the row rank of the whole matrix? Whole matrix. This is again in row echelon form. If we multiply this one by 5 by 2, so that look at here, this will become 1. So, we can say that it is in row echelon form. And row echelon form, then what is the total number of non-zero rows in the whole, in the augmented matrix B? So, it is 3. There are 3 non-zero rows in the augmented matrix B. And therefore, row rank of the augmented matrix is 3. So, look at here, row rank of A, that is we are getting here 2, and row rank of the augmented matrix A B, I am calling here 3, both are different. When both are different, it means that system is inconsistent and solution does not exist. And it is also very clear. Why it is very clear? Look at here, first row is here 0, 0, 0 and is equal to 5 by 2. What is the meaning of this one? 0 into x1 plus 0 into x2 plus 0 into x3 is equal to 5 by 2. Is it possible? Not possible. And therefore, the system is inconsistent. System is inconsistent, solution does not exist. See third example, I shall just give the final form. This, see what is this augmented matrix? This is your augmented matrix. Convert this one into row reduced echelon form or row echelon form, whatever may be. Okay. If it is Gauss elimination method, we will have to convert into row echelon form. If it is Gauss Jordan method, we will have to convert into row reduced echelon form. So, just I am going to show only you to final form of this matrix. Look at here. This is the final form of the matrix, which is in row echelon form or row reduced echelon form in fact. So, look at this matrix. This matrix is in row echelon form, and therefore, see what is whether solution exists or solution does not exist. Again, what is row rank of A? Number of non-zero rows. Number of non-zero rows is 1 and 1, 2. So, rank of A is 2. Again, this is completely 0, 0, 0. So, again number of non-zero rows in the echelon form of the augmented matrix B, again it is 2. So, row rank of A is equal to row rank of the augmented matrix is equal to 2. Both are equal, both ranks are equal, therefore, solution exists, but at the same time if you see that this rank is less than the number of unknowns are here 3, this is less than 3. Therefore, solution, how many solutions? You are going to get infinite number of solutions. Okay. So, if row rank of A is equal to row rank of the augmented matrix is equal to number of unknowns, then you will get unique solution. If you row rank of A is equal to row rank of the augmented matrix, it is less than the number of unknowns, you are going to get infinite number of solutions. Because here look at here 0 into x1 plus 0 into x2 plus 0 into x3 is equal to 0. And what from second one, what you will get from second one? 0 into x1 plus 1 into x2 minus 2 into x3 is equal to 2. Let me see from here. Of course, system is consistent, and in place of x1, x2, x3 we are using here x, y, z. So, from the second equation we get here y minus 2z is equal to 2, and the first one get 1 into x plus 0 into y plus 1 into z is equal to 2. So, x plus z is equal to 2, y minus 2z equals to 2. So, look at here, z is a free variable, z can take any value. Okay, so suppose z is equal to r, it is any real number, therefore, x we can write here 2 minus r, y is equal to 2 plus r. So, r is any real number, for every value of r, you will get x and y. So, see that you are going to get infinite number of solutions. Okay. So, we have seen 3 examples. In one example, you have seen that solution exists and it is unique. In another example, you have seen that solution exists and number of solutions is infinite, and in one case we have seen that solution does not exist. You can see from here, whatever may be the value of z you are going to choose, correspondingly you will get the value of x and y. Now, exactly in a similar situation, when x is equal to 0, that is b is 0, you will get always a trivial solution. Homogeneous system is always consistent, that I have explained. In this case, there is no need of finding augmented matrix. The reason is that the column B is always 0, because B is a 0 matrix here. Therefore, we shall use elementary operations only on A and see what is the row rank of A. If row rank of A is equal to number of unknowns, solution is unique, and this solution is unique is always x is equal to 0, because x is equal to 0 is always a solution. So, if row rank of A is equal to number of unknowns, then you will get unique solution. If row rank of A is less than number of unknowns, you will get infinitely many solutions. So, look at here, this is a homogeneous system of equation. Find the coefficient matrix and use elementary row operations to convert it into either in row echelon form or row reduced echelon form, and then you see use elementary row operations. And now, I shall not explain here at this stage how to convert this matrix into row echelon form or row reduced echelon form. See that this is 1, so we are enough, there is no problem at all. If it is 1 here, let this leading one, this one should be 0, this one should be 0. So, how to make this one to be 0? Subtract R2, replace R2 by R2 minus R1, that is from the second row, subtract first row, you will get here 0. Then you want to make this one to be also 0, so multiply the first row by 5, then you subtract it from the third row, you will get here 0, and continue this process and see that what you are going to get is a row echelon form or row reduced echelon form of a matrix. So, this is after transforming and see that row reduced echelon form is coming here, row reduced echelon form. In fact, and then see this is 0 row you are getting, here you are going to get 0 row. Therefore, what is the row rank of this matrix? Row rank of A, it is 0, number of non-zero rows 1 and 2. So, row rank of A is equal to 2, and if row rank of A is 2 and it is less than the number of unknowns. Look here, if row rank of A is equal to the number of unknowns, you will get unique solution, that is x is equal to 0 only. If row rank of A is 2, which is less than number of unknowns, you are going to get infinite number of solutions. So, therefore, here we will get infinite number of solutions. And what are those solutions? From here you see that this one, what is the meaning of this second row? That is y plus 2z is equal to 0, and from here x plus 0 into y minus 1 into z is equal to 0, and see that what you are going to get. So, rank of A is equal to 2, and that is the number of non-zero rows in the row reduced echelon form, and it is less than the number of unknowns. Therefore, you will get infinitely many solutions, and from the first two equations you will get x minus z is equal to 0 and y plus 2z is 0, again z is arbitrary. So, choose any value of z, then you see that x is equal to r and y is your minus 2r and z is any real number r. So, for every value of r you will get different x and y, and therefore, we will get infinite number of solutions. This is also another example I am leaving as an exercise for you. You can see yourself exactly in a similar way. First you find the coefficient matrix, find this coefficient matrix, convert it into row reduced echelon form and see what happens. So, I am going to just let you know final result after converting it into row reduced echelon form. See, this is in row reduced, this matrix is in row reduced echelon form finally. Okay. So, what is the row rank of A? Row rank of A, number of non-zero rows. Look at here, last row is 0, number of non-zero rows is 1, 2, 3. So, number of non-zero is 3. So, therefore, row rank of A is 3, and that is the number of unknowns, and hence if rank of A for homogeneous system of equation, if rank of A is equal to 3, that is the number of unknowns, rank of A is equal to number of unknowns, solution is always unique, and that unique solution is always the trivial solution, x equals 0, y equals 0 and z equals 0. Fine. Let us see how to find inverse of a matrix. Exactly in a similar way, first you see what is here. Inverse of a matrix means a matrix A is said to be non-singular or it is invertible if you can find another matrix B such that A into B must be equal to B into A must be equal to I, the identity matrix. Then we say that B is called inverse of A. If AB is equal to B is equal to I, we shall say that B is the inverse of A. And if it is not possible, if you cannot find such matrix B, then you say that B is singular. Okay, you can see that A and B, these two matrices are given. If you multiply A into B and B into A, see that we will get here identity matrix, and therefore, B is the inverse of A. These are simple properties of inverse. Inverse of the inverse is the original matrix A, and AB inverse is B inverse into A inverse, and AT means transpose of A takes its inverse, then it is A inverse of its transpose. And exactly in similar way, if A1, A2, AM, these are the matrices, takes its inverse, then it will be in the reverse order, AM inverse into A minus 1 inverse into A1 inverse. Remember here that row reduced echelon form of a non-singular matrix is an identity matrix. If a matrix is non-singular and if you are converting it into non-singular, if you are converting the given matrix into a row reduced echelon form, and if it is coming to be identity matrix, then the given matrix is non-singular. That is, row reduced echelon form of a non-singular matrix is always an identity matrix. And if you see the row reduced echelon form of a matrix, if you are getting any 0 row, then the inverse of the matrix does not exist, because if you are getting any 0 row in the row reduced echelon form of a matrix, then determinant of that matrix is 0. The moment you are getting a 0 row, then determinant is 0, therefore, that matrix is singular. So, how to find inverse of a matrix? Just like the augmented matrix, first you see write the matrix A, and then in place of the matrix B write an identity matrix whose order is exactly same as to that of A. Use elementary row operations on the whole matrix AI, and see if we can convert this matrix A into an identity matrix, then whatever this matrix you are going to get, that will be the inverse of A. If this matrix is not an identity matrix, that will imply that A inverse does not exist. Let us see quickly one example. This matrix is given to us, you want to find what is the inverse of this. So, write this matrix in this form. So, look at it, write this matrix, this is the matrix A, it is given. Then in the RHS part, this is an identity matrix. If this order is 3 here, remember here, if you are going to find inverse of a matrix, the matrix has to be a square matrix. So, this is 3 by 3 matrix. So, you write here a 3 by 3 identity matrix. Okay. So, remember, use elementary row operations on the whole matrix, this is the whole matrix, use elementary row operation on this whole matrix and convert this matrix into row reduced echelon form and see what happens. So, row reduced form, this one you want to be 0, this one if you want to be 0. So, subtract the R1 from R2, you will get here 0. Okay. So, let us see what you are going to get. But whatever the operations we are going to use, elementary operations on the matrix A, same operations must be used at the same time on the matrix I also, that is very important. So, look at here, we are making here 0, replacing R3 by R3 minus R1. So, look at here, replacing R3 by R3 minus R1. So, same operation has to be done here also, or R3 minus R2, let me check. R2 has to be replaced by R2 minus R1. So, look at here, this 0 minus 1, so 1 minus 0, 0 minus 0, same operation has to be done here also, same operation. Okay. So, now still this matrix is not in row reduced echelon form. You will have to convert this matrix not in row echelon form, but in row reduced echelon form. So, look at here, it is 1. So, you want this one to be 0, this one want to be 0, here it is already 0. So, therefore, subtract the second row from the first, you will get here 0, and here you want to be 1. If you want to be 1 here, multiply this third row by minus 1, you will get here 1. Okay, and see that what you are going to get finally. Okay. So, now you see that you are going to get here replacing R1 by R1 minus R3, and R2 will be replaced by R2 minus 2R3. So, that look at here, this becomes 0, you want this one also to be 0, this one also to be 0, of course this one also to be 0. So, for this one to making to be 0, so see that R1 has been replaced by R1 minus R3, so that this will be 0, and then you multiply this R3 by 2, then subtract it from 2, you will get here 0, and again from here you subtract here, you will get 0. So, see that you are going to get, now from here you are going to get 0 here after applying these two operations. Now, this element has to be 0, so R1 has to be replaced by R1 minus R2. So, see that 1 minus 1 will be 0. So, this if you are multiplying here 1 minus 0, that is 1, 1 minus 0, 1, 0, 0 minus 0, it is 0. So, 2 minus 1, 2 minus 1, so this will be here 1, minus 1 of minus 1, so will be here 0, 1 minus 2, so here will be minus 1, same operation has to be applied. So, let us see finally what you are going to get after using this operation. So, see that you are going to get this matrix which is in row reduced echelon form of a matrix, and when the row reduced echelon form of this matrix is the identity matrix, then this is the inverse of A, this matrix is the inverse of A. Therefore, look at here, this is same as this is called A inverse. And the moment the row reduced echelon form of this matrix is not identity matrix, it will imply that A inverse does not exist. And or in any case, if you see that if there is any 0 row appearing here, any 0 row appearing here, that will imply that A is singular, therefore A inverse does not exist. In this way we can find the inverse of a matrix. I shall close this lecture today here. Then again in the next class I shall be starting vector space. Thank you.